And we are live. Let me see if it is working. Should be working. Is it? Yes, it does work. All right. What is up, data dudes? Roshan here. In this video, I thought I'd go live and try to solve some data science problems with you using Python. This is the first time I'm trying YouTube live, so please bear with me if I do make some mistakes or try to figure things out as we go. But yes, with that, let's get started. So let me move my face down here. Yeah, that should be fine. And then let's switch on the display. All right. So Strata Scratch essentially is a platform that will let you solve interview questions using multiple languages and for different roles. So it's almost it's perfect if you're trying to apply for data science roles, data engineer roles, or BI analyst roles. This website is really helpful. Plus, you can sign in for free. This is not a paid plugin, by the way. This is just out of my own interest that I'm trying to solve questions. So I've selected data science here, and the language is Python. So let's jump right into it and let's see. So the first one here is most profitable companies. So the question is, find the 3 most profitable companies in the entire world. Output the result along with the corresponding company name. Sort the result based on profits in descending order. Okay. So essentially we have this, so here's the editor, the query editor, and we can select the language that we need over here. So if we run it, we can see the data set. So there's just one data set, which is great. That makes our life super easy. We just need to pick the company, which is the 3 most profitable companies in the entire world, which is present in this data set. So that's easy, not hard. The challenge is just figuring out what syntax to use to rank it and pick the top 3. So here on the data set, we have all of these different fields. We have got, oops, what happened? Okay. We've got company, we've got sector, industry, continent, country, market value, sales, profits, so on and so forth. The main column is obviously profits. If we just rank it in descending order, so if I say rank, I forgot how the rank function works. So basically you have this argument called method, and if you say max, what do you get? The built-in function max. One second, let me see. Rank function pandas. So the method, okay, max has to be in quotes. Does it work? No, yes. All right. So this does rank, but we need to be ranking the profit. Okay, this ranks everything. Okay. So if we want to rank profit alone, I think what we'll have to do is just put profit in brackets here. Rank it. Is it profits or profit? Yeah. Okay. Now I think this is ranking it in descending. So ascending should be set to false. Once we do that, we get 1, 4, so on and so forth. All right. Let me see this data set again. If I paste this here and come to profits, what is the expected output? 42.7 is the highest. Okay. And then it's 39. Okay, fine. Perfect. Awesome. So this is working the way I wanted it to. So when you rank it, it shows that 42.7 is the highest profit. And now we just need to add this back to the main data set. So if I want to do that, actually it should already be there. No, it won't be there. Yeah. So I've got to call this as rank equals this. All right. Now we just need to sort it in ascending. So if we take a look at the table again, we see that there's rank here. This has to be sorted in ascending. So sort values. How does this work? Okay. Sort values by equals, it should be rank, right? Yep. Perfect. So now we've got the rank in ascending. So now we just need to pick the top 3, which is nothing but head, dot head of 3. Yep. So this works, although the expected output is just company and profits. So if we want just company and profits, I think we could do it like this. Let's see if this works. This should not work. Yeah, it doesn't. So company, let's add company here. Company and profits. Profits, yep. Awesome. Let's try this again. What? Solution is incorrect. For a solution to be accepted, your output should match the expected solution. Values in each column. Column names and positions input. Output is case sensitive. What is my solution again? Oh, China Construction Bank is coming for me. Agricultural Bank of China. Okay. Let's look at the data set again. China Construction Bank is second. Oh, wait. Oh, there's one more rank here. There are 2 ranks. Why is there 2 ranks? That's odd. So this rank is okay. Understood. Yeah. 1, 2, 3. Yeah. So the reason for that was because I need to save this into a new data set. So let's call this final and let's save this. Now, if we just use final here, this should solve our problem. So the expected output is ICBC, Gazprom, and Apple, which is what we get. So that's it. Awesome. So that is not too hard, but yeah, this is one problem on Python. Let's go back. Let's see if we can solve another one. So this is from Forbes. This was apparently a question on Forbes. The difficulty is medium. Let's do another medium. Okay. Let's try this LinkedIn one. So I'm just going to go straight into the data set. So you have 3 data sets: LinkedIn projects, employee projects, and employees. And the question is, the problem that we have to solve is, there are projects that are at risk for going over budget. A project is considered to be over budget if the cost of the employees assigned to the project is greater than the budget of the project. You need to prorate the cost of the employees to the duration of the project. For example, if the budget for a project that takes half a year to complete is 10,000, then the total half-year salary of all employees assigned to the project should not exceed 10,000. Salary is defined on a yearly basis, so be careful how to calculate salaries. Output list of projects that are over budget with their project name, project budget. Okay. So the expected output is this. You have project titles, the budget of each project, and the prorated expense. Okay. Okay. Oh, they also have hints. That's good. But let's not look into that now. Let's look at the data sets. So you have 3 data sets. And you can preview it here. So this is the first data set. It contains all of the projects along with the budget, the start and the end date. Okay, let's remove that. The next one gives us the project ID mapping to employee ID mapping. Okay, and the last data set gives us all of the employee names and the salary. Awesome. So the first thing is we need to merge all of this. So let's do that. Let's merge. The first table is LinkedIn projects. Let's merge that. And the question is how. That's going to be inner. And the joining column is left on. Project ID has to be the column. So it's ID. Right on project ID. Okay. All right. So we are trying to join the first data set with the second data set using an inner join. I am missing the second data set, so I should add that here if I'm not wrong. I think I might be writing it with the wrong syntax, but we can check that later. Okay, awesome. So we have the first data set, which has ID, title, budget, start and end date, and the second data set, which is just employee ID with the project ID. Now, let's call this data frame 1. Let's now merge this data frame with the third data set, which is LinkedIn employees. All right. Yeah. How equals inner left on so we're going to be merging the employee ID. The employee ID has to be merged with, okay, wait, this has to go emp underscore ID and right on ID, I think. Yeah, cool. So we've got this syntax, which I think is right. Nope, this is wrong. Okay, so this is the merged data set. Let's call this df underscore 2. which contains everything, all the three data sets merged together. So we've got title, budget, start and end date. IDX is the project ID, and it's called IDX because you have one more ID here. So this is the employee ID. All right. And from this, actually, we need only a specific set of columns. So let's just kind of make it look a little better. IDX is needed, title is needed, budget is needed, start underscore date is needed. Okay. End underscore date is needed. Employee underscore ID is needed. Project underscore ID is needed. What else do we need? First name, last name, first name, last name, and I think salary. Yeah, that's it. Awesome. So we've got ID, we've got the project ID. We actually don't need this ID because there's another project ID. Let's remove this. So we've got title, the budget, the start and end date, employee ID, project ID, which is again not needed. Project ID is not needed. Let's remove this. First name, last name, not needed. Let's remove that. Okay, let's keep it for now. Let's keep first and last name. So this is our final data set. Okay. Now the goal is to find the prorated expense. Where's that? The prorated employee expense. So the expense right now on this data set is the salary for the year. So we need to find the prorated expense, for which we need to divide that by 365 because they've asked us to consider 365, and we need to multiply it by the number of days for this particular project. So let's do that. So how do I divide? Is it salary divided by 365? What do I get? Yes, perfect. So this gives me that. Now I need to multiply this with the subtraction of the two dates, which is going to be df underscore 2 dot end underscore date. Let me just check this. df to end date minus df underscore 2 dot start underscore date. All right. So if I do this, I'm getting it in seconds. How do I convert this to days? I think it's dot days. Oh, one sec. dt dot days. No. Okay. I need to import the date package, which is date time as dt. Then let's do this dt dot days. Okay, that's because oh damn, convert seconds to days in pandas. Let's see this. Object has no attribute days. Why is that? Days. The dt.second works. Oh, understood. Okay. Let me try this. Yes, okay. Cool. So the reason why I was getting an error is because I was converting this date to days and then trying to subtract it. So now when I added the bracket, it fixes everything. Let's add another field and call it days. Days. df underscore 2. Okay. So now df underscore 2 has, yeah, awesome. So now we've added the days. Okay. So to calculate the prorated salary, it's going to be nothing but, let's bring this back up, right? By the way, is the live still working? Okay. I think the live is still working. That's good. I don't know how to check if there's a chat window here. Yeah, I don't know how to do this. All right. Let's get back to it. Okay. So the salary has to be multiplied with the days, which is this df underscore 2. Let's put days here. df underscore 2. And let's call this prorated expense equals. Right. So yes, we get the prorated expense, which is nothing but the salary divided by 365, because this is a salary for a year. Then we find the salary for a day and multiply it by the number of days for that project. Okay. Now what we need to do is find the total expense of each project. So to do that, we have to group by. So let's group by, and we have to group it by the project. So title, and we need to sum the prorated expense. Yeah. Let's sum up the prorated expense dot sum. Yeah, I need to put the brackets here. Awesome. So now we've got the sum as well. Next, we're going to have to join this back. Okay. Let's call this, and we need to, yeah, we also need to round it to the next dollar amount, because the expected output is not in decimals. Okay. To round it to the next dollar amount, there's a function called ceiling. First, let me save this as df underscore 2 prorated expense 2 equals this. All right. Now df underscore 2 will have this extra column here. Wait, what? Why is it blank? That's odd. Oh, yeah. Okay. Doesn't make sense. this one should not be there, sorry, because I'm grouping it by. Yeah, sorry. So I'm grouping it by title and then I'm calling it prorated expense too, which does not make sense. Yeah, I should actually merge this. And I need to add the ceiling to this. Let's try doing this. So, is it seal? Nope. Wait. How do you spell ceiling? No. I think round up. Ceiling. Python. It's math.seal. Math.cell. Why is it called? Okay, it's seal. Math.seal. Okay. So I need to import math. All right. And then let's try this. Math.seal. Yeah, I will have to do it like this. Math.seal. Nope. What am I doing wrong? Why am I getting this wrong? Let me save this in df3. Okay. So it's math.seal. Okay, I think I will have to df underscore 3 of prorated expense. Okay, dot math dot. Wait, I think I need to use yeah. Let's close this. Let's close this. What? is this happening? Oh, do I need to reset index? No. df_3 off prorated expense. Open the bracket. Yes, okay. Now let's try math.ceil. Yeah, that's because I need to apply it. Oh, wait. You will not be able to reconnect. Why is that? Okay. Okay, dot apply. Awesome. Okay, that was way too long. All right, so we've got the number rounded up. Now we need to merge it back to df2. So df_2 has the prorated expense, but this is not aggregated to a project and it is not rounded up. So we need to bring this df3 prorated expense to df2. Let's do that. So the way we're going to do that is, let's call it df4 equals, this is not the most optimal way to do this, but anyways, df3 dot merge, we're going to be merging it with, sorry, it's going to be df2 dot merge. We're going to be merging it with df3, and should it be inner join? Should it be inner join? I think inner join is enough. Yes, inner join is enough. How is equal to inner, comma, left on. Actually, it can both be on, just title, right? Let's just do this. Now, if we run this, we get the prorated expense. But why is, oh, it's not applied. Okay. Okay. Prorated expense has to be applied here. So let's do that. Okay. Let's call this 2 equals this. Awesome. Now df4 contains prorated expense 2. Awesome. Now all we need is the 3 columns, which is title, budget, and prorated expense underscore 2. So as you can see, we just need these 3 columns, and that's what we're doing here. So we've got title, budget, and prorated expense, and I see that there are some duplicates. So let's drop duplicates. Okay. Yes, duplicates are gone. Now that's called df4. Now the final thing is, we need to pull only the cases where the budget is lower than the prorated expense 2. We can also rename this. Rename, I think it's called rename columns. prorated expense 2 should be called prorated expense. I think this should be fine. Set object is not callable. Why is that? This works fine. Oh. Yeah, okay. All right. Now we just need to select the cases where prorated expense is greater. So I'm going to have to do this. Prorated expense 2. No, prorated expense greater than DF4 budget. What do you get? Okay, true, trues, false. Okay, now we just need to pull DF4 off this. All right. So as you can see, the output, I don't see project 2 though. So there's project 1, then project 11, then it's project 12. Why is there? This does not look right. There's some issue. Let me check this. Oh, it's right. Awesome. That worked. But I think the order somewhere they've shifted it. Awesome. If I put less than or greater than or equal to, it still says solved. Okay, what about less than? Yeah, solution is incorrect. Cool. Okay, fine. Awesome. So that is 2 questions on data science. And I hope you guys found this helpful. And this is my first time doing a live. I'm still working out how these things work. So I've got this OBS software where my input mic is connected and the video is through my laptop. And I can do these cool things that, like taking my face off. I'm back. I'm kidding. Okay. This is a bit hard for me to figure out. But I hope you found this helpful. And I will see you in the next video. All right. Bye-bye. I'm back. Okay.